This video is on how to look at systems of equations of two variables on a calculator. So these are our calculator notes. We're going to look at two problems on the calculator. Y equals 3x plus 2 along with y equals negative 2x minus 4, and then we'll look at the other equation in a minute. So y equals 3x plus 2 and y equals negative 2x minus 4. So get out your calculator. Y equals 3x plus 2 and y equals negative 2x minus 4. So we're going to actually type these in the calculator. So 3x plus 2 and negative 2x minus 4. This problem is actually relatively simple compared to a lot of the problems that we might see where you are actually using a calculator, but I just kind of want to show you what happens. So clearly what happens is we see that this is a system where the lines intersect. So this is an independent system. And let's say we want to find where these lines intersect. Now we can clearly do this using algebra, but I want to show you how you would do this on the calculator. What you would do is, I don't know if you know this function in the calculator yet, but if you hit the trace button and you hit left or right, you can actually see x values and the corresponding y values that go with them. So for 3x plus 2, if you substitute in negative 0.151515 repeating, you get 1.545454 repeating as the y value. So you can see what actually happens. The calculator can show you if you hit the trace button. You can also, if you hit the trace button, hit x equals 3, and then it gives you the y value that's associated with it. So 3 comma 11 would be the y value that's associated with that. Or 3, if x is 3, y is 11. That is the ordered pair that goes with 3 on the line 3x plus 2. If I hit the down arrow, then that takes me to the other line. Okay, so it just will go down in order. So if I had 7 different things, y1, y2, y3, y4, when I go to the graph and hit trace, as I go down, it's just going to continually go down the list. So if I hit down again, I would go to y3 if I had a y3. Instead, since I don't have a y3, if I hit down again, it'll go back to y1. So it'll just cycle through everything. If you want to find where they intersect, you hit second trace. So second trace leads you to, notice in blue, there's a little button that says calc. So what ends up happening there is you end up getting options for ways to calculate things. You can calculate a value, you can calculate zeros. We'll do all those things throughout the year. But the one we want to focus on today is intersect. So that's option 5. The intersection finds the intersection. What you have to do is, if you want to find an intersection, you have to get the cursor closest to the intersection. Okay. And it will find the intersection that's closest. Now, since there's only one intersection, I could actually just hit enter 3 times and it's going to give me the answer right now. But if there were multiple intersections, I would have to get my cursor to the closest intersection that I want, and then it will find it. So I'm literally going to hit enter 3 times. Enter gives me what value I'm guessing on the first curve. Enter will then give me the value that I'm guessing on the second curve, and then it'll say guess, and you just hit enter one more time, and it will find the nearest intersection to what you have. So the ordered pair that answers this is negative 6/5, comma, negative 8/5, or negative 1.2, comma, negative 1.6. So we just found our answer. If you roll out a calculator, you can do that. Most of the questions where it's this simple, we would not be allowed a calculator, but that is how you would find the intersection on a calculator. Okay. If you want to find the nearest intersection, if there are more than one intersection, I highly recommend that you scroll your cursor close to where the intersection is, and then it will find the intersection. One really quick example as to why that's important is, let's say that I have the absolute value of x plus 5 instead of one of those other options. And then I have a simple equation like y equals 4. Notice there are two intersections. And so on an equation like this, if there are two intersections, if I hit second trace and then intersect, it will find the closest intersection. So if I want to find the intersection that's way to the left of the screen, oops, I'm hitting weird buttons right now, but I would have to actually move my cursor so that it's closer to this intersection if that's the one I wanted to find. Okay, so it will find the closest intersection. That is how you use intersection mode. All right, now let's move on to the second question, which is y equals x plus 15 and y equals negative 1/2 x plus 18. So we will type this in, x plus 15 and negative 1/2 x plus 18. So I have x plus 15 and negative 1/2 x plus 18. And I kind of see part of a blue line and not much else. So if we just look at these, we can see that this is nonsensical. X plus 15 and negative 1/2 x plus 18 will definitely not fit on my little window where I'm going from negative 10 to 10 for x and negative 10 to 10 for y. So let's look at the window button. If we look at the window button, that tells us where our x's and y's go to. If I look at my y equals, clearly my y-intercepts are at 15 and 18. So I need to move this graph somewhere where I can see more of this, where I can see where the action is going on. One thing that you can keep in mind is that you can scroll out significantly. You can go from negative 100 to 200 for x, for example. You can go from negative. I mean, I'm just randomly picking things just to show you that you can zoom out pretty significantly. Your scale, if I'm going from negative 100 to 200, I might want my x scale to be 50 and my y scale to be 50. So then the tick marks occur every 50. So I just zoomed way far out. How you scale it on the window makes a big difference. Now, obviously, I can see this now that I zoomed way far out. I can see where the intersection is. But maybe I want to actually get a relatively close look, kind of by where the intersection might be. So where the y intercepts are at 15 and 18. Maybe I might want to make a window where my x remains negative 10 to 10. But my y value might be, oh, I don't know, 5 to 25. I might want to go from 5 to 25 because my y-intercepts in this problem are 15 and 18. So that gives me a much closer, in-depth look at what's actually going on with these lines. Now I can do the same thing with the intersection. I can trace things, or I can do second trace, find an intersection, scroll close to the intersection, hit enter 3 times, and I get the actual value of that intersection at 2 comma 17. Okay, so my answer for this problem is 217. But if I kept my window where it was originally, I would have never seen it. So you might have to actually look to see where a window is. Finally, you might want to look into one other feature on the graph, and that is the zoom feature. So Zoom can do a couple different things. Notice that my window right now is a little different than what it normally is. If I need to zoom back to a normal window, I can hit 6, which is Zoom standard. What that will do is that brings me back to negative 10 to 10. Now, obviously, that doesn't give me anything for this picture, but if you need to go back to normal, Zoom standard does that.